Okay, so first thing first, hi everyone. Hope everyone is doing great here, and we are meeting here to discuss one of the system design, which is uh, which is called mint.com, a free website which helps us do some sort of spend management. So what it does is it captures the spend from our bank, and then it allows us to set some sort of alerting and notification. So this is what I got as a system requirement in one of my mocks, and I went through that, and I thought, okay, let me kind of present this thing to the bigger audience, and I think it will help improve the underlying assumptions that has been made here. So yeah, so let me go ahead and kind of take this up. So here are basically this is as a spend management, I'm kind of having some of these clarifying questions to the interviewer. So is this integration with bank would be only read only? So yeah, so this is what has been kind of stated, that we cannot go ahead and make any updates to the bank, maybe crediting or something. This is just getting a spend feedback on Mint, and then take it forward. So the next question will it be API based or SMS integration? So there were some companies, at least they were trying to do some sort of SMS reading and integration. So as part of this, basically the banks will push the information. It is an integration with the bank. And so what I'm seeing here is we'll have to basically rely on consistency of the spend information. A little buffer is fine. Data should not be lost. That is just, I'm thinking non-functional here. And also getting a confirmation, like a little lag should be fine. Next is what is the maximum time window that we want to capture the aggregation. So the intent is like maybe monthly, bi-weekly, weekly kind of thing. And the scale intent is 100 million daily active users, and 4 bank account per user, and 100 transaction per day. I mean, we are really aggressive, for shoppers. So this actually translates to these functional requirement, which is user should be able to add an account to the banking system for notification, or basically for events to be pushed, to Mint, and the banking system should send the spend information to Mint. Next is the budget alert for the spend and dashboard should be populated by the system, which is the Mint system. And user should be able to extract their spending reports, and optionally we could build some sort of recommendation system. If we have time, maybe we can think around it. Otherwise, largely this is the thing. So any further question on this? Like, does this look good from the perspective of Mint as a spend management system?
So basically, go ahead, sir. I'm saying basically, will it be like monthly budget, like household items you apply, or it will be yearly? All the options will be there.
Yeah, a good question. So here, when we are saying that we want alerting maybe bi-weekly, weekly, so I think we can also add yearly, but I don't know at that scale. Of time, does it actually matter? Because in December, if you realize that you had done too many spends, or by July you took too many spend, whether you will be able to rectify those. I think it should be the frequency should be based on your salary, like you are getting bi-weekly, weekly, or monthly, so you should have some control on that spend, probably for further up for investment need or saving need. So that is what I can think of. But if you think that this is yearly for some tax saving or some other intent, we could take that up, but somehow it is not kind of convincing me that we should try to cover yearly. Any other take on this?
And you should show the graph and all also, right? I mean, which will help you to analyze at the end of the month regarding your expense, right? That
Sure.
One of the requirements.
Sure, the banking should send the spend, budget alerting should be spent. Yeah, so this dashboard is like basically when we say graph, this could be like much more detailed story there. We can definitely build that. I mean, not exactly we'll build here in this time, but we will target it. Yeah. So anything else?
Yeah, one quick thing, it's not nothing to do with the functional requirements, but only so this whole system, it's very tightly coupled with the banking system, isn't it? So if you don't get the information or notification from the banking systems, okay, for some reasons, and then for that month we do all those calculations, everything is projected to the user, but we move on, and then after 2 or 3 months we start getting everything. So how is that will be handled, or is that not an issue at all?
No, I totally agree. And this is a kind of the thing that I in one of my previous company also faced, like we were exposing some APIs for, upselling from a small plan to a bigger plan. And there was an analytics thing that used to run, and they used to trigger our API. And we did not add any monitoring. They did not add any monitoring. So what happened is our service was up. They did not send anything for 1 month, and there was no. So at the end of month, kind of in the directors meeting, they told, okay, there was no upsell this month, and it was. It became very critical, and then we started putting all the alerts on our side, like this should be the minimum that we should receive from the bank, and from the upstream, and the upstream also started putting some alert, and something weird happened even after 1 month, like our alerts we are getting, but downstream we were not getting from their side. So
yeah, because this is not a very important for the bank, right? So it's only important for the users.
So, I definitely understand. So how do we handle upstream not sending any data? So can we trust the upstream, or with some a service level agreement, or do we have to build something? Do we have to build something to confirm it? So I think this is very interesting thing. So this is practically I had faced, so I would definitely agree this.
Okay, no worries. Yeah, let's move.
Yeah, anything else?
No.
This guy is not getting smart. Okay, so this is definitely useful, I'm seeing. Maybe I will try to cover up. Let's see. The thing is, okay, so I'll move on to the non-functional part of it. So the non-functional is, the very first thing is a scale. So here we are looking for 100 million daily active user, and consistency versus availability. This is what I'm thinking, that though this is a banking application, but this is just a human alerting, right? This is not making any transactional decisions on top of that. So I don't see there will be really a red flag if once in a while I have delayed alert or something like that. I don't see it will become immediately kind of a burning thing. So that way I'm thinking that we could very well have availability over consistency here. Once in a while, I don't see any issue, because this is just for human alerting, right? What do you say? Like, do you have any contradicting views, or no, this is just fine, acceptable?
I think it is right.
Yeah, eventual consistency. Yes.
Okay, cool. So have is basically in scenarios like if we are doing trading, crypto trading, or some automatic robotic trading, then this would have been wrong, because once a decision is taken, it cannot be reverted, right? Here it's just fine once in a while. If it happens once in a million, it happens. So latency, not much a concern. I am seeing, like I as a human, I'll not desperately go and swipe cards, of course. So if I swipe card, I will maybe swipe card 10 minutes later. So even if I have 1 minute of that latency, it should be just fine. So yeah. So another thing is the read write issue. So it looks to me this is very write heavy system as a whole. Like a lot of messages will be or events will be pushed to my system, but the reads will be very less, or alerting and all will only happen, right? So yeah, so write to the bank is not needed here. So does it make sense? Like durability, security, privacy, we have to think a bit. So yeah, till now it makes sense, right? Any question?
Yeah.
We will have any kind of notification service also regarding alerting via email or app. If you open there, only you will have.
No. It will be there. So that is what I've built one of the components here. So definitely we will have some notification. So here, if you see, user should be, the bank should send the spending information to Mint. The budget alert for the spend and dashboard should be populated by the Mint system. So Mint system will basically handle this thing. So a dashboard and both alerting both are here in the scope. So here we are saying that there will be 100 million daily active user, 100 transactions per day. So this is ending to almost like 10 billion, push events to the distributed system from the bank. And we'll have to set alerting budgeting of the 100 million events. Why did I estimate that way? Just 1 second. Okay, 100 million events of the alerting notification will happen, because not all these aggregate raw events will lead to aggregation breach, right? So here I'm saying that maybe 1 in 100 will lead to alerts. For example, if I have a budget of $500, I will do $50 spending, $100, $20. So eventually it will breach that number. So the alerting will be much less, like almost like 1 in 100 kind of thing. So makes sense, right? Yeah. So now, so this is basically, I'm saying that this is, per day. So if I divide, to the system, there are two things here. One thing is like, total events that are coming here. So total event that are coming here will be, it will be 10 billion divided by 100K. So this is coming to, 100K transactions per second, the raw data that is coming, and roughly around, maybe just 100 million alerts it will happen. And from the QPS perspective, it will be maybe 1K alerts per second. That's all, right? Makes sense, right? So I'm just skipping this storage and compute. I will jump to the high level design. We will see if it is needed. I can fill up those sections, right? So I'll just kind of explain each part of it from the functional perspective. So the very first thing is you should be able to add account to the banking for events to push the event with Mint. So here this is basically my actor. This is the API gateway. So here what it will do is it will hit the spend management service, and this spend management service, from here it will go all the way to budgeting service, and from there I can just subscribe to certain events. So this is basically the external bank here. So so this is what is, I'll just kind of highlight this to be very specific, maybe external component here. So this is visible, right? And this I will make it another external component here. So these are two components. So this is external bank gateway, and this is SMS and email gateway. So these are external systems. So that's why I kind of making it different colors, so to say. Yeah. So I'll just subscribe to certain events from here, and this guy will allow to authorize, and it will then agree to send those events to my queue. So it may have some sort of producers or wrapper at that level, but we are just assuming that okay, this guy will somehow send the events to my system, and from there on I'll consume it as a async system. So there could be sync, async, and kind of queue-based models. Queue-based model would be most suitable here because we don't want to immediately process, and it does not need to acknowledge. Yeah, and we can process any streaming. So the scale we can go and build really large scale system. So the very next thing is the banking should send the spend information to Mint. So this is actually an external contract, of course, and we need some, maybe we need some sort of monitoring here. So this guy, whatever events they are sending, I can have some sort of minimum and max rate that I should expect, and if it is breaching those numbers, then I have to create a systemic alert here. So this could answer that specific question: what if the upstream is not sending any event, right? And we could have some sort of predictive model, like based on the last week's statistics, it should lie somewhere there, so to say, like min max range, something like that. And so how does this work is the core component here, I believe, is building the aggregation system. So here what will happen is that this is very simple, like building microservice and updating the bank info, displaying the dashboard should not be a big deal, as long as we have all the statistics available somehow, and the integration part. So here this bank will kind of do the account related information ingestion, it will do. And by design, whatever queue we are using typically has a at least once guarantee. And from here on, it will go to a real-time aggregator, and then it will go to this is basically the service. So it will do three things. One thing is after the aggregation, after the aggregation, it will send the event to downstream for further alerting, and it will the second step would be like it will update the aggregated DB, and the third one is it will update this append only DB. So so this has some depth. So do you want me to go deep into this, or shall I come back later here?
Okay, we can come back later, but why they are different on a very nutshell?
No, I'm telling that there are some complexities that this guy is definitely trying to solve. So let me explain it in this way, that whenever we are getting any event, like, this will say that, at 10 p.m., Mr. X, or, spend $10 here. So it will be something like this. Like there will be some unique ID, there will be some timestamp, and then the user ID and the account ID, some information, and the amount that was kind of in certain denomination that was debited. So this will be basically captured here. And once this is kind of captured, it will go to this aggregation system. So what it will do is it will check what was the last value, basically, a debt that was created by that person. So for example, the debt that was created by that person was $450, and there is suppose an alert, a spend alert on spend limit of $500. So what happens here is the next event we are getting is, Shiva is doing, $100 of, debt on this debt ID. So this will go here, and then it will update the number, and then it will push on to the next, downstream queue. And from here on, it will go to the aggregation service. So alerting service, and it will just check that limit that, I had already set some limit. So if that limit is breaching, then it will just check from the user service, what was my kind of threshold for that, your email ID and things like that, those personal information. And from there on, it will actually go ahead and fulfill the requirements of this notification service, and create the underlying email or SMS, whatever is needed. So kind of makes sense at high level interaction.
Yeah, so that append DP is just for what you say, fault tolerance and durability.
Okay. Correct.
Okay, no
you're right. Yeah, you're right. So that is kind of an additional thing that we are thinking here, because this is a financial transaction. So as much as possible, we want to be fault tolerant, and kind of definitely accuracy or whatever is there, we want to cover. Yeah. So
I have one question.
Yeah.
Yeah, so just want to clarify. So this is a web UI, right, or it's a mobile app?
Yeah. So
okay.
Yeah.
So first time when I log in, when I create a new account, sync with my bank account, so it will be pulling. It'll be creating a I mean, I just don't have a confusion regarding that. Where is actually that process is happening, and which service actually pulling each transactions when I do from my bank.
Surely. So when I'm doing a transaction on the bank via card swipe, the bank, first of all, I will subscribe to spend events. So now when I'm subscribe to these events, what will happen is that any spend that is happening, any debt that is happening, it will be sent to my specific queue here. Once I get it in this queue, this is basically as async model that we want to follow. So first of all, what we'll do is this guy, this is the consumer. So this consumer will take maybe in a batch or whatever, it will take those specific spends, and it will check what is the current running debt. It will add to that debt, and then it will just send it to the downstream for further processing. So for example, I'll just run through a very concrete example. Let's say I had sent a $500 spend limit, and my last running aggregate was $450 as spent. Now I just did a $100 spend here, right? Something like this. This is the $100 spent I sent. Now what happens is this $100 spend, this goes to the queue, and this aggregator will pull the information, and then it will send the updated information to the downstream. It will update the aggregate, it will update the spend, and it will move on to the next object of this system. So so there are basically two blocks, this part and this part, which is kind of playing the role of aggregation and alerting.
So which service actually pulling the data from bank's gateway, like bank API?
Yeah. So there is no pull base. It is like actually bank is pushing the information.
Is that we are expecting, or is
a problem with that, right?
Why it will be a problem?
I don't think so. Bank will send that way currently in any of the bank, unless you request.
Yeah. You will have to push it, right? Pull it, right? I don't think
see,
so.
if you log into your account, you're not going to pull it from the bank. At that time. So bank will do everything in the background. So that is what you'll have to subscribe with the bank. So you'll have to have a contractual agreement with the bank. So the main system has it. So whenever you are actually trying to
because the bank will have the retry logic in order to push all these messages. Let's assume our service is down.
Yeah, it's not
in that case, you'll have to have that. Yeah, that is right. But then how your service will know about whether it is whether bank tried to push it or not. Yeah, but then there might be one way of this service to keep on querying the banks at the regular intervals.
Okay,
so that might be one way of doing it.
The way I'm saying is, the way I'm saying is, if I have to query frequently with the bank, it will not be scalable, and because we are getting too many events, right? Almost like how many 100K, what was the scale? So this was really large scale we are getting. I think 100K events per second is coming, right? So we cannot ask the bank to give me this, give me that, because it will not work in sync or full model. It has to be some sort of queue model. That is what I'm thinking here.
No, but their question is also valid. Like if the bank doesn't send you information, you don't come to know whether the information was there or not.
Sure. So that specific problem, basically a constraint. So I've just proposed one very first thing, which is like this guy will have monitoring that this is the minimum rate or maximum rate that I need to accept, and based on some sort of historic data, this is what I should get from the bank, and I will get an SLA from the bank. It cannot be that I am integrating with the bank and bank is totally irresponsible here, right? So both parties will have to be responsible for proper integration. So what they will be relying on, they will have their own kind of monitoring and alerting there, and they will make sure that anything, because they may have also some sort of queue for a thing, right? It is kind of a black box to us. So they will also have some monitoring, and if they see that there is some lag or things like that, they will have to fix it, and it will be their own internal thing. So I don't think we can push on their internal. We can only do some sort of SLA. That's all.
Okay.
And what all will be the topics in the queue?
Yeah, so I'm just thinking that it will be what is there? So this is push event account ingestion. So this is account action is debit. So the only kind of action I'm looking for is a debit action. So I can say that maybe spend, topic name will be spend.
Okay. How much
Yeah.
spent here?
So yeah. So this with this topic, I'll send to this topic, and it will go on something like that.
And remaining balance. Okay. Good.
Makes sense, right?
Quick question. So suppose you are assuming that the event is being pushed by bank to your queue, right?
Mm-hmm.
So in case it's at the real time, I'm assuming, right? Suppose I swiped the card and I got some transaction happen. So as soon as I made the transaction, it even come to the queue, right?
Correct.
So for assume like mean how many queues? So you have to make that cluster, because are you expecting if sometime if your queue is you're down and some reason you are not receiving the transaction detail from bank, so bank is not going to send you twice, right?
Okay, good question. So what we have to do here is let me kind of think through and explicitly elaborate that part here. So basically, the integration reliability, that is how I will state here. So when I'm saying, so when I'm saying integration reliability, it is two-party system, right? They cannot say that hey, I called you yesterday, you had zero balance, I will not call you tomorrow. Okay, so not like that. So what it will do is as a bank as a client, it will have all the mechanism, like it will do retry, it will have alerts, it will have monitoring, it will have like maybe some sort of buffering it will have, and we'll provide an interface. Suppose they are getting too many high error rate, so what they can do is they can cut and they can cut a step 2 on us, something like that. So because it will be a business thing that we are integrating, it's not just for fun we are doing, right? So they if they feel that we are down, they can kind of come back and raise concern with us. So similarly on our side, what we will do is that we will definitely have for scaling purpose. So our basically queue,
So
I'll just,
so that means it's a tightly integrated, right? So you are acknowledging like to bank saying like, okay, I have received this information, some kind of thing, right?
yeah. So they once they push it to the queue, they will get that acknowledgement. That's all. Or yeah,
but
and
you
or
somewhere
we can
mention API. I got confused. Anyway, no, that makes sense.
yeah. Okay, cool. So here, just for answering some of those, scalability and availability concerns. So for scalability, we will have maybe one topic, but we will have based on scale, we can have 50 partitions, right? So 50 partitions, and that way we can scale massively. I'm just making up some numbers. And for high availability, I will definitely have maybe 3 in sync in sync replicas of the partitions, right? And that way we will make sure that if one of the leader replicas goes down, someone else will take up and kind of move forward, and we will as part of acknowledge, we can tell them that hey, whenever you are sending this event, please get all acknowledgement, don't just send it to one or any or async, just get a full acknowledgement and then only send it over, so that we can kind of agree or integrate upon based on the scale requirement. So yeah, so these are kind of certain things I'm thinking. Of course we can elaborate even more given the time if we want.
One quick thing. So when you say 50 partitions, the partitions based on per bank, something like that you are thinking, or?
Okay. Yeah. So good question. So first of all, let me think about the.
Okay, no worries. Yeah, let's move on. Yeah, sure.
Yeah. So we have this 100K events that are coming per second. So if we are able to send it in some batch, I think this is still too many of it So I think we can easily do with very less partitions. So I'll just make it maybe 10 partitions. So now these partitions, I think it could be simply load balanced. We don't have to worry much about it, because if we try to impose certain things, then unnecessarily, suppose they're a rich guy, we want to club them together and things like that, then we will have to build heuristics around them. So I think we can just have it load balanced, because anyway these are agnostic, and here the aggregation is also just pulling it agnostic way and getting the job done here, right? So no need to have specific partition for a specific purpose, right? Makes sense, right?
Yeah, thank you.
Yeah. Any other question?
Yeah, I have a question. So when we support batch support in the APIs, like we have batches of messages, right? Then how our aggregation service would be consistent? Like any message can come before, like in chronological order, it might not be the same order, right? Which the aggregator will receive.
Yes. Okay. I'm just thinking. Okay. So there are certain nuances. So the very first nuance that I have tried to address, maybe I'll come to your nuance, is okay. I have very small thing here. Maybe just I will wrap up and then I will come to your question. So the very first thing is scalability. So write throughput. So this looks like very write heavy, oriented. So if we have kind of the data that is coming here, the raw data we can put anywhere, right? It's fine. Like I can just put it to any line item thing like S3 as well. But for these aggregates, probably I can use any wide column DB with write ahead log support. So maybe Cassandra, Scala, or Dynamo DB. And if we are using any sort of cache here, maybe I don't know if cache is immediately applicable. We could use key value store. Anything else is there? I think there is nothing else. So let me jump to your question. So so before that, the very first thing is how do we see all these things are at least once guarantee, right? So how do we make sure that we have almost like exactly once kind of model? How do we achieve that? So what I'm thinking here is that whenever a certain event comes, that event will go to a certain partition. We will just make sure that maybe based on UUID, it will go to partition. So it is not truly agnostic, but deterministic. I want to make it. So any or even better, I think what I will do is the partitions will be partition key will be based on this thing hash of user ID, basically something like that. So what happens there is I just want an ordering guarantee here. So this will basically provide some sort of ordering guarantee at least for a given user. So this will be actually useful to address to your specific problem. What if it is coming out of order? What is this same event is sent twice? So at least we will have some control that all the events of that person is coming in the same partition. So so let's say let's go first of all by a happy scenario here. So what happens here is, let's say I got $100 event here, and this is basically the event that came here, and it went to the real-time aggregator here. So what all it is supposed to do? So the main problem statement is this is at least once, this is at least one, everything is at least once. How do we make it kind of exactly once via some sort of model, maybe idempotency or whatever. So what I will do is, first of all, I will read this event, and then I will check that this event was already not part of the running aggregator thing. So there will be a timestamp mentioned here. So here also maybe I have this timestamp. So based on the timestamp, I can make sure that okay, the $450, this timestamp is actually greater than this $450 that was attached here. And that way I know that, and there will be a det ID as well. So I know if the same event comes twice, I can simply drop that event because it was already used in the last aggregation, right? So for example, if it is already 550 and I get that event 2-3 times, so I see that the last time the debt ID that is coming to me is exactly the same, or I'm getting maybe even older events. So I'll just discard those events and move on. So this is one thing I'm thinking. And if yeah, so how do I make sure that the rest of the things are also following this paradigm? So the very first thing is, whenever I get first instance of that event, I will check the aggregate, and then I will send the aggregate here. Like step one will be send the aggregate. Okay, so this will just send the aggregate here, and this will be sent to the downstream, and this itself is a at least once guarantee. So here it could very well happen that we may get repeated alerts, but we can live with it. It's not a very big deal, so to say. So next what is happens is, the very next step is that because this is something anyway we are it is at least once only. So if we are sending to twice, it doesn't matter. Now the next step is we update the sum here, and once the sum is updated, then we will push it to the append db. So this is basically the 3 steps that we want to cover here. So that will actually guarantee that any event that is getting sent twice or thrice, we have a mechanism to kind of eliminate double calculation here. So does it make sense? Shall I help re-clarify this? Or maybe if there is any gap, I can work towards it.
Right. For at least once guarantee, yeah, it makes sense. I was just more curious about the ordering thing. Like if the order is not there, or the order is misplaced between 2 transactions for same debt or something like that.
Okay, so in theory, what I know is that if you send for the same user ID, if you are able to send the event to the same partition, so basically partition key you will use as a user ID or hash of user ID, then it will provide the ordering guarantee. So the only catch could be we will have $100, $100, $125. So suppose this is the queue, so it could be 100 and 100 and 125. So this is basically a repeat, basically a wrong duplicate, right? So now what I'm thinking is that since it is already providing this kind of guarantee, that ordering, so if I'm getting the same event again, so I had done that aggregation here, right? So if I had done that aggregation, I'll just check, oh, this debt ID was already used here, and the timestamp is also exactly the same. So just drop this thing, so to say. So this is kind of very heuristic, but I'm just thinking it might actually work. So
yeah, so for the partitions, the ordering is maintained in a partition, right? So therefore,
yes.
So if you send the same users, whatever that hash based as a partition, so then it should, the ordering should be maintained there. And the next thing what you're saying is, if you get duplicate events, right? So then how do we handle it? Yeah, I think that makes sense. Yeah.
Bloom filter can't use here, right? Okay, that's what DB, isn't it? For checking the duplicates.
No, it's the duplicate events in the queue. They might be physically there, right? Yeah.
I thought aggregating same thing again and again in the DB, but already it will be filtered out at the queue itself.
Yeah.
Cool. That makes sense. Yeah. And just one more thing, like if for some transaction, a real-time aggregator service is running a bit slower than other transaction, then also there will be order mismatch, right? When we are sending alerts, although I think we can live with that.
No. So it will not happen like that. So what will happen is, let's say that we have the aggregator that is running a bit slow. So what could happen is, suppose there are 10 partitions and one of the partition is running slightly slow. So only these events will be processed little slowly. So that person, let's say that we build a really great system, and for most good purpose, 30 via the SLO approach. Suppose SLA is 1 minute, and SLO is 30 seconds. So what will happen is we will still have some a levy here for end-to-end thing. So one of the partition, if it is bombarded with too many information, only thing is there will be just lag. It will not impact because the things will be sitting in this queue. It will not get lost per se, right? It will be sitting here.
In the queue.
Then it will be sitting in this queue.
Yeah, can I ask a question as well? So we have a requirement to process 100K per second. Yeah, how can we prove that our real-time aggregator is able to process such amount of transactions?
I am getting your point. I think we will have to think a bit more about it. So here, when I was giving this number 10, I was just thinking from the Kafka perspective, which is kind of wrong, because the big picture here would be the aggregation part of it and transaction. We would require much more partitions. I kind of understand here. So what will be the bottleneck that is I'm thinking is probably this atomic update. So one function that I know of is update and set and update kind of that kind of model is there. So we can use something like this. I mean, based on whatever is the data, update set where amount is X. So basically update amount is equal to Y, set where amount is X. So I mean, this is a very loosely defined syntax, but what we intend to do is only for those people where only for the raw, if this is applicable, then only it will do here. So with this will be an atomic write. So it will not lock for really long, right? So this is some paradigm we can use here. That is what I'm thinking. There will be more to it, but I'm just thinking, it will just query the value and then it will lock an update and just move on, so to say. At least the update will be atomic. I mean, to some extent. Yeah.
For dealing with 100K requests, we can create multiple instances of real-time aggregator and sync them. No.
Yeah. So we will already have multiple instances of real-time aggregator, and this will be also kind of definitely sharded, and so these things will be, I think, there by virtue of design. The only thing is like when we I think transaction is the biggest thing that is a bottleneck. So the only thing I could, at least this is what I'm thinking, is can we have some sort of atomic update? If we are able to kind of justify some sort of atomic update, then we should be able to achieve it. That is my thought here.
Yeah, I think one more suggestion is, if possible, the real-time agree is more like a producer and consumer, right? So a real-time consumer can be split into two. One can be update the DB, and one can be one can be a producer, one can be a consumer.
Okay, so what will happen there?
So the real time, one of the consumer actually read it from the first queue and read it and process it, update to the DB, and you will have another consumer which actually read from the DB and send it to the another queue, which for used for alerting.
Yeah, so that is what we are doing here. Alerting is a separate component. So
but the real-time aggregator is doing both, right? It's actually reading from one other queue and actually producing into another queue.
Yes.
So the problem is, if you're having a scaling, you want to scale up, right? I mean,
yes.
If you have a producer and consumer, actually you can, if you want to increase, you can actually increase only the consumer. If you split into two, right?
Yes.
So basically, there should be line from DB to the queue directly, right? I mean, which will act as a consumer.
Yeah.
You mean like whatever updates are happening, we'll have some sort of CDC coming from there?
No. I mean, if example real-time aggregator, you will have another consumer.
Okay.
Two consumers, like split the real-time consumer logic, both consumer logic and producer logic into one consumer, right? One component right now, right? Instead of that, you're separating the logic of real-time aggregator into two, and both are running independently. And the real-time aggregator one, example, it is actually reading from the first queue, and that push into DB, and and another consumer, which is real-time aggregator 2, which is actually reading from DB and updating into the another queue, and that is used for alerting.
So when there is another, actually the second consumer, it is reading from this queue and it is doing the aggregation and alerting. So the effort will be similar only, right?
So, but load would be reduced, right? Because that same real-time aggregator is doing two jobs, right? He's updating to the DB as well as sending to the another queue. So better this, I mean, one of them will update to the DB, and from DB, again, you'll have one real-time aggregator that will update to queue.
And it will not be real-time.
I would propose not to update at all.
Come again.
I would propose not to update balance at all, because we do not need to update balance by each new transaction. Yeah, we just need to insert it to that database, and we can calculate balance on fly. And update balance, we can update in just one time per day.
Oh, batch kind of thing, right? I mean,
we just we receive a transaction, we insert it. It's like event sourcing. Yeah, we insert it somewhere in transaction table, and each time we can by account do it on. It will help us to eliminate update transaction at all. Yeah.
Actually, there was some voice cranking. I actually did not get it fully.
Yeah, Nick, there was some voice problem.
Okay. Yeah, sorry.
Now it's okay.
I would propose not to update, not to update each time. Yeah, when we dequeue something from queue, one transaction, yeah, we do not need to update balance. Yeah, because in this case we will have a lot of transactions per second. Yeah.
Yes. I understand. So how do we optimize it?
And we probably could also have the deadlock issue. Yeah, because you will have some maybe yes or maybe not, but you can just insert transaction to table and commit. Yeah, and update aggregator in memory. Yeah, and then when aggregator failed or something like this, you can calculate balance on fly, because you know account ID. Yeah, you know account ID, and you can calculate. It will look like event sourcing. Yeah, like event sourcing. And in this case, you need just a batch update of whole accounts at once per day. Yeah, you will move aggregate. It looks like, how to put it, you will calculate current balance, the last pre-calculated balance plus like in Windows. Yeah, but you will keep just for today transactions and prefix sum for before.
Actually, I'm not getting. Another thing is we want to do almost in real time. So are you suggesting to do a big batching and then take some time by end of day update the aggregates or something like that?
It will real time. Yeah, but you just can eliminate update each time. We can do update balance once per day. Yeah.
No. So what will I understand? So if we are doing an update once per day, so what might happen is, especially in the current paradigm of Kubernetes world, where the containers could go 5 times in the day, right? And we are totally fine. So if we have some running aggregates in the memory, then it could get lost, right? I do the aggregation, and it will get lost. So that risk is there, and we cannot wait till the end of day to update here. So yeah, so this is what I'm thinking. I think there some more effort will be required here. At least this part of exactly once is somehow taken care by correct sequence of events, but scaling is not handled correctly.
Yeah, but I was talking about another approach. Sorry,
Yeah,
it was
please.
misunderstanding. Yeah,
No,
we
no,
do
no.
not need update. Yeah, but we can calculate when new transaction arrived. We just need to know current balance. Yeah, which is balance up to date. And how can we calculate it? We can took balance from yesterday. Yeah, and we need to add just transactions for today. Yeah.
So the risk there is that we might in a given day, if those running calculations are in the container in the VM, then what might happen is we might lose sometime those aggregates because we did the calculation, and end of day if you push it to the DB, what if the server has already gone down, and the durability guarantee will be lost, so to say. So I think there is some competing concerns here.
Yeah, but when we dequeue transaction from queue, we need to insert it. We need to insert and commit, and it will let us consider transaction as durable. And then after commit, we can calculate balance. And when we calculate balance, we took balance from yesterday and just add transaction for today, and it will let us eliminate update, and we will never have an issue with deadlock or something like this.
I'm kind of partly getting, like, we will have like 1 day old data in the DB, and rest of the active aggregations will happen in this real-time aggregator, and we will also append to this. So even if this goes, we should be able to repopulate everything here. Looks like a thing. So what other things here, like is that a feasibility, or it will become more complicated to debug and all? Like, how do we resume, where do we resume, and things like that? Does someone think that it could have nuances or complexities? Like
from my point of view, it's more reliable solution because it let us avoid deadlocks. Yeah, and it's how real bank system works.
Yes. So Nick, when you're saying update, you mean to say update in a DB?
Yeah, we just need to insert to DB. Yeah, when we dequeue from queue, we need to insert new transactions. Let's say we have 10 transactions for current user for today. How can we calculate balance? We just need balance. We took balance from yesterday, and plus 10 transactions which we had for today. Yeah, and then at the end of the day, we can submit by job, and it will took balance from yesterday and plus transaction for today, update current balance.
If I understand correctly, Nick idea is basically avoid the DB update for each time to avoid the locking, right? So
yeah.
So he's saying go ahead and every time insert each transaction, and while the things comes to the update, so do that update using a batch job. Is that a correct understanding, Nick?
Yeah, it's correct, because update is not as cheap in case of performance as insert. When we insert something, we will never have deadlock or something like this, but with update we can have some issues, some troubles. As example, deadlock.
So update aggregate DB, right?
Yeah, update aggregate DB.
Okay.
Yeah, if you use Cassandra or something like that, you don't need to update. It's just always an insert statement. Yeah. So.
Right. That's what Nick is referring to.
Yeah, but your aggregator, real-time aggregator, if it's running in a VM and that fails, so if you're doing a balance on fly, so then that might be something of a concern, isn't it?
Yeah, we will have to read all transactions each time when we calculate balance. Yeah, we need to read all transactions for today from DB. Yeah, we cannot.
Okay, got it. Yeah. So that is one solution. Yeah, no problem.
Yeah, so I'm just noting this as an alternative. So for fault tolerance, replay full day events, and
I do have a question about. Hello.
Yeah, sure, go ahead. Yeah,
I have a quick question around your append DB. So,
okay.
What's the intent for that? I mean, what I can read it that you are having for the fault tolerance.
Yeah.
Is that correct?
Yes. So I'll describe this. I think I did not get a chance to cover this up. So yeah. So what will happen is whatever events we are getting from the queue, we will put it will run in the step 1, 2, and 3. So what if suddenly this aggregator is down, or this alerting system is down, or any of the downstream is down. So what we can do is from this append DB, we can just replay events as long as we can go back. So similar to queue, it will be read from append only DB and find the corresponding entries. It will see the timestamp and update or drop the row based on the last aggregate stamp value. So for example, I had a replica, basically the DB failed for whatever reason. So if we replay from here, we can totally kind of create the aggregate DB, assuming that we have last 1 month of sort of information. We are not storing for a year, but that could be overkill. But we can with this we can push all the events here, and automatically it can get generated. Or from this we can just stream the events here to the consumer, and it will from fresh if this is gone, it will start calculating all the aggregation, and it will send the events. So this is kind of a little sketchy, but I'm just thinking append could be used to provide some sort of fault tolerance.
So I have one question. Like instead of append, why don't you use the queue itself? So to go back and then read from the queue.
So the queue actually it may have certain constraints. For example, what if the queue has just 1 day TTL? So if it has just 1 day TTL, and it could very well happen that this queue is not owned by us. I mean, it could happen that this queue is owned by this bank, and we are just the consumer of it. It could happen. So there we cannot even control this TTL. So actually, I had done a similar integration in our org, where any of the events that are coming, they had it was their queue. We were from GCP, we were consuming the events from there, and it had just 1 day TTL. So given a chance, I would kind of append put it in my append DB, so that I have much bigger maybe last 30 days information I can store here, and I can also do some sort of analytics or any other downstream here. I mean, fault tolerance is the main purpose. Fault tolerance is the main purpose.
So if you're saying for the queue is like 1 day TTL, right? For that sense, we should have separate thread to run to just read from the queue and put in the one internal DB, the source of truth, and then we can run the analytics on the source of truth, like whatever DB we store internally.
Yeah. I think separately we could do that. This is what maybe we could directly write it to append DB. That could be possible. That is particularly possible. Then this will come out of this transaction of 3-step kind of thing. I think this should be possible. We can directly somehow put to the DB. What do you guys say here? I mean, we will have some mechanism to put directly here.
Yeah, that is what exactly Nick's suggesting, right? So
Yeah,
every time you bring it to the
Yeah.
queue and transaction and keep on adding there.
Yeah, so this kind of simplifies this, and then we will just worry about the queue and the aggregate, and that too we can keep in memory. And if something fails, I mean, we will do some sort of end of day update. Yeah, I think that is possible. And if we are falling short of it, why don't we replay from the append.db and kind of we will have this. So this will be some sort of dotted one, not exactly a hard line, and based on our requirement, we can kind of poll this thing. So yeah, this is also doable, I think. Yeah.
And this for dashboard purposes, you're using append.db, right? For reading.
Yes, maybe I'll have to kind of connect those dots as well. So yeah, so that is actually not particularly visible here. How do I build dashboard? So let me just think about it. So dashboard, what all things it will need?
I mean the dashboard in the sense when I log into my account in web UI, I will see some information about my account, right? Those are building on top of the append.db. Okay.
So I'm thinking actually any kind of dashboarding might require some advanced data store, like maybe something like time series DB, or and on top of that, it will be much easy to visualize like last one day what was my spend. But actually that will create a whole system in itself. So so that is what we are trying to build here. So what else can we do for the dashboard? So this alerting is coming, but the dashboard we want to see like last one day, 1 week. We are actually not storing that information here. I think unfortunately that is not particularly covered here at the dashboarding part.
That's okay.
Yeah. And yeah, so a couple of things I think I had this one we discussed quite aggressively, that we can just read from the DB, keep a live one, send the aggregates, and at the end of day just update the DB, something like that. And that will batch versus real time, like we can have some yeah, so we can do maybe daily week aggregate or something like that, or we could do a stream where we can have maximum 2-minute lag or something like that, if you don't want to lose time. And transaction transport, I think we already discussed. I don't have anything else, and we are kind of done, I think. Yeah.
So we will whether we'll be using multi-master, since it's a write heavy system for the DB, and queries are QPS is like 100K, right?
I think multi-master would become very complicated. What we can do is we can use white column, maybe I don't know, can we use quorum consistency and white column data store, and if once in a while we are getting some loss of information, I think we can live with that. But in general, monthly this is anyway getting flushed out. So yeah, so I think I can use some white column data store, and that will provide with quorum consistency we can get almost like the accuracy that we want. And so that will actually distribute the load pretty easily, right? So instead of single master and going to multi-master, which will get very complicated, I think, how to coordinate between the two masters, and how it could end up being hard conflict. So here at least it will be much softer in eventual consistency model. So I will suggest maybe, yeah,
it will be some sort of time series DB, right? Because every month we will be flushing out, right, the info for the corresponding user, isn't it?
So when we actually think about time series DB, what is the thing is, all these things can be black boxed. This full area what we have designed, there will be just a time series DB that can do all these things here. We don't have to worry about anything, so to say. If we have really good time series DB, we don't have to literally build anything here. That is what my thought is. So yeah. So, anyways,
and that will be a pull notification, right?
So what I'm saying here is, So this part basically whatever we are building here. Let's say I'll just click it, and then yeah. So this almost like this part, the time series will do all these things out of the box. So let's say we are using InfluxDB or something like that, and the full stack, it can do all these things out of the box. We don't have to do any of these design, so to say. If you are just ingesting the raw data, I can just just do alert setting on the InfluxDB. It will magically solve everything. We don't have to do any of these mess here.
Hey, one thing, when you are saying we want to flush the previous data, so how does MENT work then? So don't you have to keep the previous data at all? You just flush it after every month or a certain day?
You should keep it for analytics purposes.
What I meant is, like, this will be this running aggregate. It will be month will be one of the kind of parameter here. So when the month rolls over, then it will be starting with a kind of zero thing, right? A zero balance, a zero debt that for that person. So not exactly deleting, but it will, because we are rolling to the next month, so it will start off from zero. That is my intent here.
But let's say if you want to prepare a yearly report, something like that, right?
Yeah, so that is only for the reporting, you mean to say.
So that's a stats part, right? So we need to, do we need to reinitialize every time? I mean, it's only for this purpose, right? Alerting purpose, monthly alerting purpose you are sending. So every month, every start of the month, you put the zero, right?
Yeah, but still, whatever happened to the whole year, you would still need that data somewhere.
Yeah.
You don't want to delete it, isn't it? Maybe in compressed form. I don't know. I'm just thinking loud. Yeah.
No. So what I'm telling is, it will not be deleted. I mean, that I told in haste that we will just flush. Flush means actually what I meant to say was that once the month rolls, the aggregator will know that I am just aggregating for this month. So this is my baseline. If I have some dashboard here, it will somehow know. So let me kind of just, I know this will again not cover all the aspects, but let's say there is some sort of dashboarding. So at least whatever is captured in the aggregator system, can I just ask this guy, hey, give me all your last month's data or blah blah, whatever is there, and this guy will actually from last I can just roll back for the given user ID, and for the last n months, what is the what was the last updated debt. So it can just show me up. But as we keep on going, adding scope here, it will get very complicated, and almost like it will become like a time series DB that we want, basically a professional solution, so to say. So yeah, so this I know that it has a lot of maturity, and it can provide almost like everything out of the box. It has graphing, alerting, integration, actually a lot of things. So let me just see. Yeah, see this stack. So it has what all things. These are the ingesters that it has: system stats, database, networking, queues, apps. So this is a telegraph, a generic integrator here. This will push to the InfluxDB, which will be a time series DB that can do time based and attributes based, metric based aggregation. And whenever it is doing some aggregation, it can tell to the capacitor for any alerting purpose, like runtime aggregation. And for visualization, it has a chronograph here. And once the attributes actually aggregated attributes are shown to this, basically via alerting, we can have anomaly detection and a couple of things. So this is a professional solution. So I don't think we will be able to make this up, right? Yeah, we will not be able to. That is my
bundle,
thought.
right? It's a bundle service.
Yeah.
Yes. Yeah. So yeah. So this is this is a platform they are making. So only some part of it we can emulate, but not everything if we want, then I will say, why don't we buy a product or get it as an open source solution and directly integrate with it rather than trying to do a lot of these things. So yeah, so that is my thought here.
Yeah.
But again, it could be debated. Yeah.
Cool. Yeah. Thank you.
Cool. Then I think we had a really great discussion, and there were a lot of kind of open questions and whatever not. So yeah, so I'll just stop my screen sharing.